In this video, we are going to look at the power rule of differentiation. Now, what if you were given a function such as this? F of x is equal to x raised to the power of n. What is the derivative of the function f of x? Now, the derivative of this function will be written as f prime of x. And this is equal to n multiplied by x. And you need to subtract 1 from the power n. Now, f prime of x, that could also be rewritten as a dy dx. So that will be the same thing. This is n multiplied by x raised to the power of n minus 1. So now let us take some examples based upon this principle. So if you are given a function f of x, and this is equal to x raised to the fifth, what is the derivative, or f prime of x? So this is going to be, I need to take 5 to the front and multiply by x and raised to the power of 5 minus 1. So this is going to give us 5x to the fourth. So that will be the derivative of x to the fifth. Try this one. X to the 100. So f prime, that is going to be 100. And that will be multiplied by x raised to the power of 100 minus 1. So this gives us 100x to the 99. So that will be the derivative. How about this one? So y is equal to x raised to the power of 2/3. Now you need to know that the reason why we have dy dx here, it is as a result of the fact that the function was called as y. So we have y here, and in order to write the differential or the derivative of the function, you need to write dy dx. So this is going to be now 2 over 3, that is going to come to the front. Well, and then this will be x raised to the power of 2 over 3, and that will be minus 1. Now, 2 over 3 minus 1, what is that going to be? So we know that 1 is the same thing as 3 over 3. So dy dx, that is supposed to be 2 over 3 x raised to the power of 2 over 3 minus 3 over 3. And so this should give us 2 over 3 multiplied by x. That will be raised to the power of 2 minus 3. So that gives us negative 1 over 3. So this will be the answer to the question. 2 over 3 multiplied by x to the negative 1/3. Now, you could also rewrite this answer in this other way. This could be rewritten as 1 divided by x raised to the power of 1 over 3. So that is what you have. Now, bear it at the back that if you have x raised to the power of 1 over 3, that is the cube root of the variable x. So you could write it this way or this other way. Okay. Here is another one for you. Y is equal to x to the negative fifth. What is the derivative of that function? Feel free to try it out yourself. Now, this will be dy dx. That is equal to negative 5 multiplied by x raised to the power of negative 5 minus 1. So that should give us negative 5 x raised to the power of negative 6. That is the derivative. How about this one? Y is equal to x raised to the power of negative 1 over 5. What is the derivative? So it comes off as easy. Now, we take negative 1 over 5. This will be multiplied by x, and this is raised to the power of negative 1 over 5. So minus 1. So we need to work this out. Now we know that 1, that is the same thing as 5 over 5. So I'm just going to change that and have it be 1 over 5 multiplied by x raised to the power of 1 over 5 minus 5 over 5, basically. So this will be negative 1 minus 5, which gives us negative 6. So this is going to be negative 1 over 5 multiplied by x raised to the power of negative 6 over 5. So that will be the derivative of that function. Let's try this one. What is the derivative of 1 over x? Now, how are you going to do this one? So the first thing we need to do, we need to change this and make it log in an indicial form. So this is going to be x raised to the power of negative 1, because if you have 1 divided by a variable, that is the same thing as that variable raised to the negative 1. This could actually work in the same way if you had a number here. So here we have a variable, and that's still going to work the very same way. Now f prime of x, that will be negative 1 multiplied by x raised to the negative 1 minus 1. So this gives us a negative x raised to the power of negative 2. This is f prime of x. Now, if I want to rewrite this, this could be rewritten as a negative 1 divided by, now we have x raised to the power of negative 2. So that will make x to become a denominator, and the 2 will now have a positive value. So this could also be rewritten as negative 1 divided by x squared. This will be the derivative of the function. In other words, that is if you do not want to write it this way. Try this one. Y is equal to root of 3x. So we need to change this form into an indicial form. Well, I just need to write the y there for now. So this will be 3x, and this is all raised to the power of 1 over 2. Now, if I had two variables, a and b, or two terms, a and b, and this is raised to a particular power, this power could be distributed over each term within the bracket, so that we could have a to the 6th power and b to the 6th power. So I am going to apply that principle upon this expression. Now y is going to be 3 raised to the power of 1 over 2, and this is multiplied by x raised to the power of 1 over 2. So I know that the power of half of a variable or a term is actually the square root of that term. So this is just going to become root 3. Well, but this will be x to the half. Now I need to work with this one, while this would serve as a coefficient. So we have dy dx. And root 3, that is going to serve as a coefficient. That's not basically going to be worked on. We need to work on the part which is the variable. Then after that, we'll multiply the answer with the coefficient. Now, how do we work this one? It comes off as easy, as we have done in the previous examples. So this will be 1 over 2 multiplied by x raised to the power of 1 over 2 minus 1. So dy dx, that is going to be 1 over 2 multiplied by x. Now 1 over 2 minus 1, that should give us negative 1 over 2. Now, while it's possible for you to leave the answer in this form, You could also go further. So let's try to do that. Now this is going to be root 3 multiplied by 1 over 2. That gives us root 3 over 2. Now this is multiplied by x raised to the power of a negative half. So this could be rewritten as a 1 divided by x raised to the power of half. That is reasonable because anytime you have a negative in front of the power of a term, you could change that to this. So if the term happens to be x raised to the power of half, and this is what the answer is going to be. But if you have x raised to the power of whichever term, let us say n, then that is basically going to be 1 over x to the n. Now, we could also change this form into its surd form. So let us write it. This is going to be root 3 over 2 multiplied by root x. So while this is one way that the answer could be written in, you could also change it to a more basic surd form. Now, I know that if I had a root a over root b, that could be rewritten as a root a over b. So I could change this stuff and make it to look in one form. So let us try to do that. Now dy dx, that will be 1 over 2. This will be multiplied by root 3 over x. So this is the most basic form of the answer to the term, or to the form of the function y is equal to root 3x. So let us try out other ones. What if you were given a function f of x is equal to 10? What is the answer for the derivative of this function? Now, we do not really have any variable attached to 10. So how are we going to do it? Now, what I'm going to do is place an x with a 0th power, which is actually reasonable because x raised to the 0th power, that is 1, or any variable or term at all that is raised to the 0th power will basically change to 1. Now, if I multiply 1 by 10, that gives me 10. So 10 is the same thing as 10 multiplied by x to the 0th. So let me use that one. Now f prime of x, that will be 10, which is a coefficient. So I'm actually going to keep it out and work the differential with x to the 0th. Now you know that this should actually come to the front. So this will be 0. This is multiplied by x raised to the power of 0 minus 1. So basically what we have here is 10 multiplied by 0 multiplied by x raised to the power of negative 1. And this is obvious. This is going to become a 0 because we have 10 multiplied by 0 multiplied by x to the negative 1, which is going to change to a 0. Now, what does this tell you? Anytime we have a constant or a number which is not in terms of a variable, the derivative of that term, that is going to be 0. So if we have 20, the derivative of 20, that is 0. If you have 40, that is going to be 0. If you have pi, that is still going to be 0. If you have e, now bear in mind e is equal to 2.272 approximately. So that is still a number. It's a constant. So that's still going to be 0. The derivative of 1, that is 0. The derivative of 0, that is still going to be 0 because 0 is still a number. The derivative of 1000 or any number at all, that is going to be 0. So just hold that to the back of your mind. Now, how about this one? F of x is equal to pi over square root of x. What is the derivative of this function? So, as you know, we need to change this form into a more explicit form so that you would actually be able to see exactly what is happening. So this is going to be x raised to the power of 1 over 2, basically. So changing this is pi over, well, that should no longer be over. So I need to take this and make it to become on the same line with the pi. So that is going to make the half to take a negative power. So that will be multiplied by x raised to the power of negative 1 over 2. Now pi will serve as a coefficient, so that is going to stay outside. So f prime of x, that will be pi multiplied by negative 1 over 2 multiplied by x raised to the power of negative 1 over 2 minus 1. Now, we have negative 1 over 2 minus 1. What is that going to give us? So that should basically give us negative 3 over 2. Now, if you multiply negative half by pi, that should basically give you negative pi over 2. And this is now going to be equal to, well, rather multiply by x raised to the power of negative 3 over 2. So that is f prime of x. But you could change this form into its denominator form, or maybe change it to its square root form. But that is actually going to be very hard, or I should rather say it's actually going to be a little bit tedious. So if you want to do that, you could go ahead and try doing that. It's going to help your brain. Let's try out this one. What if you have f of x, and this is equal to x squared divided by square root of 2x. So what is going to be the derivative of this one? Now, we need to change this into an initial form. So this is going to be x squared multiplied by, or rather, let me take it more gradual. So this will be 2x, and the whole stuff should be raised to the power of 1 over 2. Now, as you know, I could distribute the power of half to each term within the denominator. So that will be x squared, and this is divided by 2 raised to the halves multiplied by x raised to the halves. Now, this is the same thing as a, now, I need to rewrite it on this other side. So this is x squared over root 2, and this is going to be x raised to the power of 1 over 2. So I need to take this one and bring it up. Now, I could actually do it that way, or just use the form of the division of terms which have the same basis and different variables if they are divided together. So if you have a raised to the m, and you also have a raised to the nth power, and they are divided, this could be rewritten as a raised to the m minus n. So that is exactly what I'm going to do with these variables. So this becomes 1 over square root of 2, and this is multiplied by x raised to the power of 2 minus 1 over 2. Now what is that going to give us? 2 minus half. What does that give? So this basically should give us 2. I could make it 4 divided by 2 minus 1 over 2. Now how is this actually done? How do you change this to this? And how do you know which values to use and make it a new fraction in such a case that the fraction could reduce to the number in the previous step? How does that work? Now what you need to do is to take the denominator of the other fraction and multiply it by the number. So whatever number you get, that should be divided by the denominator again. So in this case, we have 2. If I multiply 2 by 2, that should give us 4. So that will be 4 divided by 2. If this was a 3, then I will take 3 and multiply it by 2. And that should give us 6. And that 6, that will be divided by the denominator, which will be there, which will be 3 in that case. Now this is actually easy because if you have fractions which have the same denominators, you could actually work your arithmetic with the numerators within that fraction. So this basically should be 4 minus 1. Now 4 minus 1, that is going to give us 3. So this gives us f prime of x. F prime of x, that is 1 divided by root 2, and this will be multiplied by x raised to the power of 3 over 2. So that is the answer to the question. Now let us try out more. What if you had f of x? Well, I should rather call it y now. Just you need to know that f of x is the same thing as y. So I think I would rewrite it. So this is f of x. Or you could recall it as y or any other variable. You could call it g, you could call it p. Whichever way it is called, you should be able to understand. So this is a 2x cubed minus 5x squared, and you have plus 7x minus 10. So what is going to be the derivative of this function? I could write the derivative as a f prime of x or as dy dx. So this will be, for this one, that is going to be 2. And we're going to have 3x raised to the power of 3 minus 1. Now 3 minus 1, that is 2. And we have 5 multiplied by 2, x raised to the power of 2 minus 1, which is going to be 1. So basically, you find that the powers of the variables in differentiation, they always get reduced by 1. Now, we know that this x is basically raised to the power of 1. So I'm going to reduce that by 1. And that is going to give us 7 multiplied by x rather, raised to the power of 0, which is going to get reduced to 1. Because anything that is raised to the 0th power, that is 1. Except, of course, 0. Because 0 raised to the 0 is undefined. Now we have negative 10. If you differentiated 10, or any number for that matter, which is not attached to a variable, that should give you 0. So this is going to be 2 multiplied by 3, which is 6. 6x squared. And you have 5 multiplied by 2, which is going to be 10. So we have negative 10x. Then this will be plus 7. But that basically is the answer to the question. How about this one? What if you have g of theta, and that is equal to theta squared minus 1 over 4. Well, I think I would rewrite it as theta over pi and plus pi. What will be the derivative of this function? Now, first off, you need to know that the subject of this function is g. So this is g of theta. You could rewrite it as a y or p, or whichever form you really want to write it. That doesn't really matter. But we know that the function is g of theta. So in this case, theta is the variable. It means that we do not really know what theta is. So in order to write the derivative of g of theta, I need to write g prime of theta. So this is going to be 2, and this will be multiplied by theta, 2 minus 1. This will be minus, we have 1 over pi, and then we need to differentiate theta. And if I differentiate theta, that should give me 1. So this is what I have here. Now for pi, if I differentiated pi, that will give me 0, because that is a constant. So we have 2 theta. This is divided, or rather minus 1 over pi. So that will be the derivative of the function. G prime of theta, that is 2 theta minus 1 over pi. That is the answer. Now try this one. Let's see, you have a p of alpha, and this is equal to alpha over pi minus 4 over alpha squared. And this is plus 6. Well, this should be alpha. So this is alpha squared, and you have a square root of alpha. How can you find p prime of alpha? Now this should come out very easy because we have done it in the previous example. So we need to rewrite this stuff. I'm just going to rewrite it up here. So we have, well, p of alpha, that is 1 over alpha multiplied by well, 1 over pi rather. Just trying to make some mistakes here. So this is 1 over pi multiplied by alpha. This is minus 4 multiplied by 1 over alpha squared. This is plus 6 multiplied by alpha raised to the power of 1 over 2. Now I know that this could be rewritten as a minus 4 multiplied by alpha raised to the power of negative 2. And then here I have 6 multiplied by alpha raised to the power of 1 over 2. So this is what I need to differentiate. That is going to be p prime. So this is p prime of alpha. Now what is the derivative of 1 over pi multiplied by alpha? So that basically should be 1 over pi, because 1 over pi, that is the coefficient of alpha. Now the derivative of alpha, that will give us 1, because that will be alpha raised to the 0th, which gives us a 1. And 1 multiplied by 1 over pi, that is still going to give us 1 over pi. So we just need to leave this one out. Now just hold that at the back of your mind. If you have 7x and you needed to differentiate this, that will basically change to 7. If you have 7 theta and you needed to differentiate that, that is going to be 7. Any variable that is raised to the power of 1 and is attached to any other constant, the answer is going to be the constant. So if we have a 4y and we needed to differentiate 4y, that is going to be 4. If you have x and you needed to differentiate this, you need to know that this was actually 1 multiplied by x. So the answer will be equal to 1. Now, how about this one? You'll have minus 4, and that is multiplied by alpha raised to the negative 1 over 2. So this is what I'm going to do. I will take the negative 2 here, and that will be multiplied by alpha raised to the power of negative 2 minus 1. And this is plus 6. This is 1 over 2 alpha raised to the power of 1 over 2 minus 1. So this is going to be 1 over pi minus, we have minus 4 multiplied by minus 2. So that should give us positive 8. And this is alpha raised to the power of negative 2 minus 1. That gives us negative 3. Now we have 6 multiplied by half. Now a half of 6, that is 3. So I have 3 there, and this will be alpha raised to the power of half minus 1, which is the same thing as negative 1 over 2. So this could be rewritten, as a 1 over pi plus 8. Well, I think I'm going to take this a little bit up and make the alpha to go down. And so this is what we have. Plus, we have 3 there, and square root of alpha. So this is basically the answer to the question. Now, what is the derivative of trigonometric functions? So we just want to deal with trigonometric functions a little bit. Now, if I have f of x, or could also be called as y, and this is equal to sine u. Now, you need to know that u is actually a term, a mini function in terms of x. So it could be anything, but just know that u is a mini function in terms of x. So if I wanted to differentiate this, how would that look? So this is basically going to be f prime of x, which is same thing as dy dx. So that is basically going to be sine, well, should cut it out. That should be cosine u multiplied by the derivative of u. Now the derivative of u, I'm going to represent that with a u prime. That is how to write the derivative of sine u. So if I have sine of 5x, that is going to be u. So dy dx will be cosine. I need to rewrite the u there, as you can see from the formula. So that will be 5x. But I need to take 5x and differentiate it with respect to x. So that will give us 5. And now the answer should be 5 cosine 5x. That is the answer. So that is basically the form that you take up the derivative of that trigonometry. How about this one? cosine u. So this should be dy dx. That will be equal to sine of u multiplied by u prime. That is the derivative of cosine u. How about tan u? What is the derivative of tan u? So the derivative of tan u, that is going to be sec squared u prime. Well, u multiplied by u prime. That is going to be the derivative of it. Right. Now, we need to know that for cosine, the derivative of cosine, that should actually be a negative sign. So I need to write a negative here. Now, bear in mind that the derivative of cosine, that is negative sine u. Just hold that. Now, what is the reciprocal of sine u? That is going to be cosec u. So what will be the differential or the derivative of the reciprocal of sine u? What is the derivative of cosec u? So that is written as a negative cosec. Now I'm going to rewrite this because of space. Cosec u, that could be written as this. Okay. So what I'm going to do, I'm going to rewrite this as a negative cosec u. So this will be written as this. And then you have cot u. And then you have u prime. So that is what is the derivative of cosec u. How about sec u? Now sec u, that is the reciprocal of cosine u. So that is going to be sec u tan u multiplied by u prime. You always need to multiply it with the derivative of the function that is attached to the trigonometric function. Now the last one, we have f of x, and that is equal to y. So we take the reciprocal of tan u, which is a cotangent. That will be cot u. So dy dx, that is going to be negative cosec squared u prime. So these are the first derivatives of our trigonometric functions. And of course, I have another video that goes into the next set of derivatives of the trigonometric functions and how calculations could be done using them. So feel free to check that out so that you could continue on this course.